How many ways can you synthesize the following compounds? Is one synthesis better than the other? So it means that we have at least two syntheses to look at in this one. So let's start by looking at the compound itself. So when we look at this, the product that's given to us, we can see that this is actually an ether. Okay, and the way that we have learned how to make ethers is by SN2 reactions. And of course, this right here tells us it's an SN2 also. But when you do an SN2, there should be some things that should be going on in your mind, and that is that when you have SN2, you need to have a substrate, preferably an unhindered one, and you need to have a nucleophile, preferably a good one. Okay, and in this case, it's SN2, so it kind of targets you a little bit. If it was SN1, you don't need such a great nucleophile. Okay, but for SN2, you need a nice, good nucleophile. All right, so those are the things that we want to look at. So then it's telling us that there are more than one synthesis. So how do you determine how to make this compound? So again, when you're looking at an ether, the main thing you should focus on is the oxygen, okay? Because oxygen or the heteroatom is where the breakage point is going to be, all right? So you have to fragment this compound. And when you fragment it, you can fragment it two different ways. And that's the whole point of having the two different syntheses. So the first fragmentation that we are going to do, and you can do whichever one first, it doesn't really matter, but the one that we are going to do now is going to be here. That's the first fragmentation, which means that you're going to have 1, 2 carbons on one side, and then 1, 2, 3 carbons chain, and then 1 extra carbon on the other side. Okay, so 4 carbons on the right hand side. Now the oxygen belongs to the fragment on the right hand side. So we're going to break this one apart first, and then we'll see what we get, and hopefully then the second fragmentation will be a little bit easier for us. Okay, so I'm going to write the retrosynthesis arrow so we can see where we are going with this. Okay, because in retrosynthesis, remember, we start from the product. Okay, so we have 2 carbons here, and then here is our fragment. I don't do much, okay? I try to keep things simple, so I'm just showing my fragment. I'm not even starting what I have there. And then the other fragment is the one with the oxygen, and then I have 3 carbons and then 1 carbon coming out. Okay, so 1, 2, 3, and 4, and then here is the fragment. Now the fragment cannot just be a fragment, it has to be something, either the substrate or the nucleophile. So how do you determine what should be the substrate and what should be the nucleophile? Well, the general thing is that wherever you have the oxygen is going to be the nucleophile, and wherever you don't have the oxygen is going to be the substrate. The substrate now actually needs a leaving group. That's how it's a substrate. So what kind of leaving group do you want? Well, the best kind of leaving group, and the best kind of leaving group is going to be a bromine. Okay, so all you have to do is wherever you fragmented it, just put bromine there, and that's going to be your leaving group then. Okay, so that's the substrate. So then what's your nucleophile going to look like? The nucleophile will still be the same, which means you still have the oxygen, that hasn't gone anywhere. You still have all the carbons, okay, but now the oxygen is going to get a negative on it. Okay, so this becomes an oxide, or as we call alkoxide. Okay, so the alk group is all the carbons that you have. Now a negative cannot exist by itself, you need to have a counter ion. So what kind of a counter ion will you choose? Any positive ion will work. So you can use potassium or sodium, that's fine. Now sometimes, when you're answering questions for me and you forget to write sodium, don't panic, it's completely okay. But if you are paying attention, then you will always tend to write that sodium or the counter ion with it. So that's the first fragmentation you can do. Okay, so now let's go ahead and draw the compound again. So here we have oxygen and then this. So now I'm going to do the second fragmentation. The second fragmentation is going to be on the other side of the oxygen now. Okay, so which means the oxygen is on the left hand side. So I still have the 2 carbons on the left side, and I still have the 4 carbons on the right hand side. The oxygen has shifted now. Okay, so now this will be a little bit easier for you, because now you know that I need the oxygen over here. Here is the fragment, and then Here is that fragment. Okay, so 1, 2, 3. As you're working through this, I highly encourage you to write your numbers on the carbon, so that way you make sure that you don't eat up any carbon in this fragmentation process. Okay, because you're not supposed to be losing any or adding any carbons in here. Okay, or any atoms for that matter. Even the oxygen actually was already there. Okay, so again, your nucleophile is going to be the one that has the oxygen in it, and the substrate is going to be the one without the oxygen. So let's go ahead and write that out. O minus, and again we need a counter ion. If you need to give yourself a change, you can write potassium, but you could also write sodium. That's totally fine. It's up to you. How do you feel today? Do you feel like a sodium or do you feel like a potassium today? Okay, so then here you still have this fragment, and then where the breakage was, that's where you need the leaving group. Okay, so that's your substrate. So which means that in the first case, okay, in the first fragmentation, this is the first one. So in the first fragmentation, these are your nucleophile and substrate. And in case of the second one, and I'm doing this completely in a confusing manner because I should use red color over here, right? And then I should use the blue color over here because this is a second fragmentation. And in this case here is our substrate and nucleophile. Okay, so we've decided that these are the substrates and nucleophile we need. Now what we have to think about is which one is better, because that's being asked in our question, is one synthesis better than the other? So how do you decide that? Which means we need to look back at the mechanism. The mechanism says it has to be SN2. So in SN2 you need the substrate, which we have the substrate here, okay, and the substrate in the second one also. The substrate in SN2 should be unhindered. The nucleophile should be a strong nucleophile. So if you want to look at the nucleophile first, yeah, we got a good nucleophile here. We have a good nucleophile here also. Okay, both nucleophiles are good. The only thing about the first nucleophile is that this one is kind of bulky. Okay, it's a little bit big, whereas the other one is kind of small. This is just ethoxide, just 2 carbons, so that's pretty small. Now let's look at the substrate. Okay, the substrate here is primary substrate. The substrate here is also primary substrate. Okay, and remember again, for substrate, primary is going to be better than secondary, which is going to be better than tertiary for SN2 mechanism, and this is SN2. So primary is going to be better. So both of them are primary. So now, which means we need to look at something else in order to make up our mind. So what we need to look at then is the steric hindrance, okay, because we need our leaving group to be unhindered, okay, sterically unhindered. So when you look at the first substrate, you can look at this bromine, and it is really very open and available, okay, to leave. So this carbon right here is easily accessible. On the other hand, if you look at the carbon in the other substrate, this carbon is not easily accessible because this isopropyl group is kind of causing a little bit of steric hindrance. Okay, so because of that, the ethyl bromide, this one becomes a better combination to give our ether. Can you do it with the other one too? Yeah, I mean, like if you had to do it, if you don't have anything in the lab, you could try it out, but you might actually not get such good products. If you try the first one, you should get good products in that. Okay, so that is how you decide what kind of substrates you want and which one is better, okay, when you have ethers.